This is a handheld vacuum. It is fairly simple in nature, but very powerful. In this video, you'll find out how the vacuum is held together, how it is turned on and receives power, how it creates a powerful suction, and how dirt that is taken into the device is held back so it is not sucked into the engine. Let's start at the front of the vacuum. This is the dirt cup, sometimes called the dust bowl. This is where the dust and other particles are sucked into the vacuum. This powerful suction action comes from a lack of air being created inside the dirt cup. This creates a drop in pressure in this area, and since air always moves from high pressure environments to low pressure, the air on the outside of the dirt cup starts to rapidly move to its inside. The air moving so rapidly is the force that pulls everything else along with it. It pulls hair, dirt, and even small objects into the vacuum, all due to this fast-moving air going from high pressure to low pressure. The next object the air and dust meet is the filter. This is a part of the vacuum that stops larger particles but allows air through. These filters can be made of things like foam, fabric, paper, and other materials. All these different filter materials have one thing in common. They all have very small holes that go from one side of the filter to the other. These holes are large enough to allow air through, but not much else. These small holes can provide a bit of a problem though, because they make it harder for air to move from one side of the filter to the other. As more and more dust and gunk builds up on the dirt cup side of the filter, it becomes even harder for air to move through the dirt cup and across the filter. You can see this in the simulation when we add additional material into the dirt cup. It obviously makes it harder for the air to move through this region. This means that the engine needs to spin the vacuum's fan even faster to overcome all this resistance and keep the suction power up, which is why it is always a good idea to empty the dirt cup after every use. To do so, you push on the dirt cup release button. As you can see, it has guide pins that move along a track on either side, keeping it in line. This button also has a spring that will push it back up after the pressure pushing it down is released. Now that the dirt cup release button has been pressed, you can grip the dirt cup and move it away from the body of the vacuum, which is this whole back section. Once the dirt cup is free, the filter can be easily taken out and the dirt cup tipped upside down over a trash bin to empty it. Remember to put the filter back into the dirt cup before attaching it onto the body of the vacuum once again. When you hear a click, you know the dirt cup is fully restrained. Let's move on to how air is sucked into the vacuum. This is the impeller housing. It is made up of three pieces: the front volute, the impeller, and the back volute. The front volute and back volute are guided together and held in precise relation to each other by these guide pins. Once together, the body of the vacuum is clamped over the leader pins of both volute halves, keeping them and the fan centered and in place. As long as the two halves of the vacuum body are screwed together, the impeller housing will not move. The front volute's job is to help keep the impeller fan centered and guide air toward it from the dirt cup through its center hole. Behind the fan is the back volute, whose job is to guide air into a vortex pattern as it is pushed past the impeller fan. It can do this because it is designed with these stationary spiral-shaped blades. The formed vortex spirals around the motor, cooling it down before the now heated air is expelled out the sides of the vacuum body. We now go back to the impeller fan because without it, the hand vacuum is useless. This fan is spun by the motor via this drive shaft. It will spin at 38,000 revolutions per minute in strong hand vacuums and as low as 5,000 revolutions per minute in a weak one. In this flow simulation, you can see the difference in suction power when the impeller is spun at 38,000 versus 5,000 RPM. In both cases, the impeller fan being spun very quickly is what creates the suction. The air is pushed outwards by the blades of the fan as it spins. This creates a low pressure zone in the middle of the impeller. This low pressure zone is where all the magic happens. This is where the device gets all its suction power. Where it gets its actual power is from the battery. But as you know, batteries need to be recharged every now and then. This vacuum's battery is recharged by this jack plug port in the bottom of the handle of the vacuum body. The last part of the vacuum I want to show you is not a part that anyone gives any thought to, but is still a very cool mechanical piece of the device. This is the power switch, also called the on-off switch. This is the switch housing. It protects the internal switch mechanism, but it still allows easy access to the user of the vacuum to turn it on and off. This is a style of switch called a sliding switch. It can be moved from left to right by the user. To turn the vacuum on, the user pushes this red plastic part to the right. This pushes a black switch underneath, which in turn pushes a metal slider. This slider goes from touching two metal plates with only one touching an electrical contact to two touching electrical contacts. This action closes the circuit by connecting the motor to the battery, thus turning the vacuum on. When the user is done vacuuming, they slide the switch mechanism to the left, reversing the process and opening the electrical circuit, breaking the motor's connection to the battery. You might think this sliding switch mechanism would be too easy to turn off without human intervention. The motor's spinning might vibrate the switch to the off position before you are done vacuuming. That is what this ball and spring are for. As you can see, the ball follows a track. As the switch is moved from left to right and vice versa, to get the ball over the hump requires more force than the vibrations of a motor will provide. It requires a human to push the slider by hand. Now you know how your vacuum works, so the next time you look at how dirty your couch or chair is, and you go to your vacuum to quickly clean it, you might give a second thought as to the amazing engineering that went into your handheld device and how everything works in sync to get the job of cleaning your furniture accomplished.